Okay, good afternoon, everyone. Thank you for waiting, and welcome to today's Twitter space on how Copernicus can help you with your seasonal allergies. My name is Dimitri. I'm a contractor to ECMWF, who are our hosts for today. That's the European Centre for Medium-Range Weather Forecasts. And I am delighted to introduce to you a panel of speakers who are going to be discussing with us this topic. It's estimated that around 150 million Europeans suffer from chronic allergenic diseases. And current predictions have it that by 2025, half of the entire EU population will suffer from some sort of chronic allergenic disease. And here we are today, the 31st of March, 2023. We're already a month into spring. So we're starting to see symptoms of hay fever coming up around the place. I'm very interested to get into this topic and find out more about how we monitor and forecast pollen and how pollen has an effect on our daily lives in more ways than you might imagine. So with me today are three experts. I have Vincent-Henri Peuch from ECMWF. Hi, Vincent. Can you tell us a bit about what you do?
Hi, Dimitri. Hi, everybody. I'm Vincent-Henri Peuch. I'm the director of the Copernicus Atmosphere Monitoring Service at ECMWF. And I'm managing the program that is offering these forecasts of different pollen species we will be talking about today.
Super. Thanks very much, Vincent. We also have Mikhail Sofiev from the Finnish Meteorological Institute. Mikhail.
Okay, I'm Mikhail Sofiev from Finnish Meteorological Institute. I'm a research professor there and responsible for atmospheric composition modeling in the institute, and in particular for pollen dispersion modeling and a little bit of observations as well. Thank you.
Super. Thank you very much. Also with us on the line today, we have a special guest, if you like. It's Carla Jones from the European Federation of Allergy and Airways Diseases Patients Associations. Hi, Carla.
Hi, Dimitri. Hi, all. I'm welcome. Really appreciate being here to discuss the impact of pollen on the patients that we represent at EFA. So EFA is a Brussels-based EU-level organisation that represents the voice of over 200 million patients living with allergy, asthma and COPD and other respiratory diseases. I'm the president of EFA, and in my other day job, I'm the chief executive of Allergy UK, and we are one of the members of EFA. EFA is a membership organisation of 45 national associations supporting those 200 million patients living with these diseases across 26 countries in Europe. And we do advocacy work at EU level and at our national levels. We focus on projects at EFA, we do collaboration at global level, and we focus on information, prevention and care for those patients that we are representing and working on behalf of. So we welcome the opportunity to discuss this huge issue that affects the lives of those patients that we represent.
All right, super. Well, thank you very much, Carla. So as you just heard, we have a meteorologist specialized in pollen dispersion. We have the head of the Copernicus Atmosphere Monitoring Service, which has a suite of services amongst which are related to pollen forecasting. And we have the president of the association representing allergy patients in Europe. So this is going to be a very interesting discussion about pollen and about how we forecast it and about what all this means. So I'd like to, first of all, draw your attention to the pinned tweets in the Twitter space. This is an area just above the speakers where we're going to be sharing relevant links and information for you to follow up on the topics that we touch upon today, because, as you know, we only have 45 minutes for this event, and there's a lot of ground to cover here. So there'll be background links popping up there. One of them I would advise you to look at is a bit of the background about how pollen counting started. It's an amazing story about a man called Dr. Frankland, and we're going to be, I can't get into the detail, but we're going to be posting a link to that, so look out for that. All right, let's enter the discussion. So first question I have, and I'm pretty sure it's an obvious one for many of our listeners, but just in case, I'm going to ask Carla to explain to us, what is pollen? You know, what's the problem here and how does it affect our health?
Okay, this could take more than 45 minutes, so I'm going to do a very brief summary.
Thanks.
So pollen grains in a sense, are transported from the male DNA of grasses, flowers, trees to the female parts of those. They're microscopic in size, they're different shapes and surfaces. Most species of pollen can produce allergic reactions. And some are more common at causing allergic rhinitis or hay fever. So, for example, grass pollen, 95% of people with allergic rhinitis can have is grass pollen, 20% it's birch tree pollen. And then you have wind pollinating non-flowering plants, and they tend to produce masses of pollen grains, which go out into the atmosphere. So it's within the atmosphere, within the air. And then the effect on health, when we're breathing in those pollens into our bodies, for some people that can cause through the nose health issues with allergic rhinitis, with the eyes rhinoconjunctivitis, and bronchial in the lungs bronchial asthma. So in your body, if you're having an allergic reaction, you create antibodies, IgE, immunoglobulin E, antibodies, your body's response to pollen and other allergens. And actually, the symptoms can be itchy eyes and throat, sneezing, blocked nose, watery red eyes, headaches, sinuses are blocked, real shortness of breath, real problems breathing, and we need to breathe to live. And actually becoming very tired, huge impact on quality of life. And then there can also be cross-reaction with fruits and vegetables for pollen allergy syndrome for food. So very quick summary there of pollen and how it affects our health.
All right, super. Well, thank you very much. So, I mean, this happens every year. It's part of the reproductive cycle of these plants. So it happens every year. Can I ask Mikhail to comment for us on how are these pollen volumes changing? I mean, are they increasing? Are they decreasing? And what's the driver for these evolutions?
Well, good question. Once again, a big one. In short, it's changing. We know that the area of forests in Europe is growing, so there is a reforestation in our continent, which means that pollen like birch is growing in the amounts. That's one of the drivers. So the change of our land use, change of our agriculture, change of our forests, grasslands is one of the most important drivers. The second one is certainly climate change. When the weather becomes more favorable to the plants, if we get more water in some parts of Europe, the amount of pollen also increases. In some other parts where the situation becomes more difficult for the plants, the amount of pollen is decreasing as well. And another part, not related immediately to the amount of pollen, is timing when it comes. And in fact, it is maybe more serious for many people, because when the season comes, when the plants start flowering, the allergy reactions will show up no matter what. The amount of pollen is usually enough for that. But the more important question is when it comes. And here the primary driver is climate change. We are getting warmer, which means that most of seasons start earlier. And in many cases, they can end later, in fact, because, again, there is more favorable conditions. So in short, the situation is changing. It's different for different types of pollens. And the climate change and our ways of using land are the most important drivers.
Wow, okay. I mean, that's a cluster of different effects all coming together, with the net result being more people are exposed to more quantities of pollen for a longer period of time. I mean, this has got to have, an effect on their health. And to explore that a little bit further, I'm going to turn again to the voice of allergy patients in Europe, EFA, the European Federation of Allergy and Airways Diseases Patients Associations. And I'm going to ask Carla to talk to us a little bit about this issue in Europe, which is obviously the area that EFA represents. So what's the extent of the issue in Europe, Carla?
Well, as you mentioned earlier, there's about 150 million people plus in Europe who are actually having reactions to these allergens, airborne particles. And there's an estimated cost of about £150 billion per year through lost working days, health costs, etc. It's really challenging, but they do believe that, studies show about up to 40% of the population are living with this pollen allergy. Geographically, it varies because it depends on the different types of pollens in different types of countries. So for for example, if you're looking at trees, grass and plants, lots of the trees are birch, hazel, alder, oak. But so from the UK, for example, birch pollen is extremely high. And that's because for the reasons that Mikhail talked about, and also because it's a very beautiful tree. It doesn't shed a lot of leaves. They love it in urban planning. So even though we have the highest birch pollen probably in the globe in the UK, we're putting more and more birch trees in everywhere. So actually we're growing it through our own aspects of sort of urbanization. In the South Mediterranean countries, you kind of get more species like olive trees and cypresses, causing pollen allergy symptoms in large populations. And then obviously pollen from grasses, which is found everywhere, normally peak in the summer months. And as I mentioned, that there's also plants like ragweed, and ragweed is normally found or originally found in North America, but actually is across Europe now and growing. And that can produce up to 1 billion pollen grains. So, and it's coming later in the season. So there's, air concentrations could quadruple in Europe by 2050, and climate change, they're saying, would be responsible for 2/3 of this increase. So there's a lot in relation to the European population, and there's a lot of, the work that's being done by our other partners here today is really, really important.
Okay, and so you mentioned grass. I think you said that grass is the one that affects the largest number of people, but this happens at different times. The different plants flower at different times, so that affects people on different timescales. Can you tell us, is knowledge about current pollen counts or predicted pollen counts for the different species useful for doctors and patients?
Oh God, yes, completely and utterly. I mean, if your quality of life is constantly impacted in relation to sort of air pollutions and pollens in the air, what you need to know is actually what pollen is it that you're allergic to, because actually not everyone's allergic to all of those. It would be very different for very different people. But you also need to know when is that going to be most high, and then how can you avoid, because the only thing you can do is avoid the pollens, and you can't avoid pollens because they're everywhere. So you need to know where there's going to be high concentrations through the monitoring of pollen and forecasts. When that also links back to the climate change weather forecast. So, we at EFA are very much aware that pollen's closely linked to climate change, and the temperature, the prevalence of pollen allergies is increasing. So it's really important that we actually have truly EU-wide real-time pollen monitoring network. We've been advocating for that, and we think this mechanism that could provide timely information and forecast to the public will help healthcare professionals and patients in the management of their disease. So in short, yes, data and knowledge on pollen levels is extremely important, and those digital technologies and tools that are being introduced, such as the Meteo pollen air techs that are coming through, are such vital tools for the patients that we represent. But there is a patchwork of information at the moment through national authorities, and actually we need to have that far more joined up across Europe.
Okay, well, it sounds like that is a very sticky challenge, a very European challenge, one that we're not unfamiliar with in European affairs. Okay, so it's clear, though, that it's very important for patients to be able to have an understanding of what's coming ahead so that they can take preventive measures and for them to know which species affects them. I'm going to ask Mikhail now, how is it that we observe pollens? I mean, how do we count them, and how do we sort of take a measure of them?
Okay, so basically here I have a good piece of news that Europe, in fact, has the best organized observational network for pollen among all countries in all continents in the world. It's called European Aeroallergen Network, which operates for more than 40 years already. It's a bottom-up network. It was not organized from above. It was organized at very local level by hospitals, by aerobiologists, by universities, who just started measuring pollen, started counting it. And then they came together some 40 years ago and organized this network, which is a bottom-up network. And that's actually unprecedented. And in worldwide scale, it is the best organized network existing to date. However, the measurements which are existing today are based on device which was put online 70 years ago in 1940s. It was invented in the middle of previous century and practically stayed unchanged since then. It is manual device. It is very laborious to measure pollen. Actually, trained aerobiologists have to spend hours and hours every week to count pollen, which is on, stuck on this sticky slide, which is used to observe it. So in that sense, this network produced enormous amount of information. There is something like 600 stations today in Europe, in total, observing different types of pollen with different level of regularity, and about 300 of them are working really on a regular day-by-day basis. So it's a big network, and it is an enormous amount of work behind it. The upside here exists as well. Last 5 years, we saw a game changer evolving, and that is called automatic pollen observations. So the difficulty there is very high. It's not a big deal to notice the particle coming, but it's very difficult to say what type of pollen it is. And whether it is birch or grass or alder, different people will get symptoms. So we have to say what pollen it is. And this is where the problem is. We were able to measure pollen decades ago, but recognizing it on the fly while seeing it in the air, that technology is coming basically the last 2 years, and it is maturing right now in front of us. Thank you.
Thank you very much. And that's fascinating. So we've gone from actually having a sticky piece of glass or a petri dish where pollen gets stuck to it, and then you've got these biologists staring at this thing and trying to figure out what kind of pollen it is and counting it, to very recent change to an automatic device that is able to do this. And I think that's a testament to how technology sometimes takes a long time to have an impact. Let's now turn to another technology that we are very excited about, and that is space technology. So I'm going to ask Vincent-Henri Peuch to talk to us a little bit now about predicting pollen concentrations with space assets. So Vincent-Henri, is it possible to predict pollen concentrations as we predict the weather or air quality?
The short answer is yes, but it's difficult. For a long time, actually, because of the need to have information about pollen in advance, there have been forecasts, but they have been done in general with statistical methods. So you're in a place A, and you use the time series of the past time series that you know, temperature, etc., and you try to predict on each year what will be the start of the pollen season. The problem is that pollens are small particles, as Carla was mentioning, and some are so small that they can travel distances. So hundreds of meters, tens of kilometers, hundreds of kilometers, and even thousands of kilometers for the small ones. So it means that in order to forecast, you need information at the scale of Europe. And that's where the forecasting technology that has been established for weather and more recently for air quality that we operate at ECMWF and part of Copernicus could be applied to pollen. So it was quite a wild dream some 10, 15 years ago to try use this technology for forecasting pollen. And that's what is done now. So now we provide the forecast of pollen for 6 of the most allergenic species. So most of these that Carla mentioned, all across Europe and throughout the year, because as Carla hinted already, depending on the different species and where you are, pollen season starts very early in the year and ends actually quite late in autumn.
Okay, that's I mean, that's excellent. So there is the possibility. There are the numerical models. It is possible, but as you said, it's very tricky. I'm sure other people are also curious. How is it possible to get info? Because of course, I understand that these models take in information from in situ as well, but there's also the space component. So what's the relationship there? How is it that pollen is sort of monitored from space?
So first of all, the meteorological parameters are critical, of course, for the transport of species, etc. You need to know the winds, but also for the maturation of species and the release of the pollen grains. So the weather forecast, which heavily is based on the on space observation, not only in situ is important as well, is pivotal. Then what you need to do, and what is maybe the trickiest part in pollen forecasting, which Mikhail knows very well, is forecasting the amount of pollen that will be ready for release in each square of Europe, and then to predict the progressive release of this pollen in time. So there is actually two difficulties. The first one is to forecast the weather. Everybody is familiar with that. The second one for pollen is to forecast the amount of pollen of the different specific species, but also at which rate they are being released. And that's why we see with so much enthusiasm also the advent of real-time pollen observation, because it means that not only we can verify the forecast a posteriori, as we do already. So after the fact, yes, we can verify by using the observations. But what's exciting is that if the pollen observations are available in real time, it means that we can use that to adjust the forecast and to use it as the starting point of the forecast. So that's, I think the name game changer was mentioned already, but it's really true in that case.
That is very interesting. Of course, a forecast is based on previous observations, and the older those observations are, the less you can be trustworthy that the forecast will be accurate. But if you have a real-time source of data, of course, your forecast is going to be much better. Could you comment on how, say, how reliable these forecasts are today, and maybe how this will perhaps change in the future?
Well, we do now mostly a posteriori because the number of sites providing real-time observation are still very limited. They are popping in, they're popping out in different parts of Europe, Switzerland, Germany, Baltic states, Finland. So it's coming. But in order to have a wide view every season, we look at most areas in Europe where there are pollen traps and observation, and we evaluate the different forecasts for the 6 species that we are considering: alder, birch, olive, grass, ragweed, and mugwort. And on this, we compile an assessment of the forecast. And the result of the latest campaign, which was to assess the forecast of last year in 22, was actually surprisingly satisfactory. We were even quite stunned by the performance of the system in general. Of course, it's not perfect everywhere, but that was really maybe unexpected that forecasting technology based on predictive models and no longer based on pure statistical models start to be quite good in picking up the start of the season and also the development of the season as an information to provide to the doctors and their patients.
Well, thank you. I mean, that is fascinating, and we're at the cutting edge here. And I mean, this is indeed going to really have an impact on how patients and how doctors can approach treatments and mitigating effects. So let's move now from talking about the pollen forecasts to talking about personalized medical information, because that's where all this is sort of heading. Carla, can I ask you, what is it that allergy patients lack or really need compared to what they have in terms of pollen awareness?
So I think in relation to personalized medication, because everybody is unique, so that's why it's personalized medication. That's what we're talking about. Majority of patients with allergy, actually, especially with pollen allergy, can live untreated. Quite often people talk about allergic rhinitis as you've just got a runny nose, get on with it, and actually don't really understand the real seriousness of the symptoms and the impact on quality of life. There's a lack of information. And it's fantastic to see this stuff coming through, because there's a lack of information on the types of allergy, types of pollen allergy that people have, unless they get proper testing. And even trying to get that testing is very difficult at healthcare level, I'm afraid, for a lot of patients. But to actually begin to get that information will be fantastic, because actually it will help as we said earlier, sort of the doctors and the patients to work at a personalised level, that will actually, what's also important as well is the air quality and the impact that has, but also information on climate change is huge, because as was mentioned earlier by Mikhail, the climate change is having a massive impact on pollen, and that's having a massive impact on people living with the disease. So information is needed on pollen levels and air quality to help and support the millions of people living in Europe with respiratory diseases that's impacted. We have longer, drier summers, increased CO2, more humid, stormy weather is also another major issue, and actually having that, and that's they've seen linked to increases in pollen and concentration in the air. Stormy weather, which we're getting more of, can have a massive impact, especially on asthma and allergic rhinitis and breathing. So there's a lack of that knowledge, and this coming through is fantastic because it can have a major impact, because that also then enables the healthcare professional and the patient to look at the timing of their healthcare. That helps them to start looking at preventative methods that they need to do, what treatments they do, what medications they do. How do you as an individual then avoid going to certain places because the pollens are going to be really high then. That's what's really important, and that's what's lacking, but is coming, which is fantastic.
And of course, location is very important here, because there can be huge differences in the kinds of pollen that are released depending on where you are. So if you're planning a trip, this is very important. And when you're having that trip, super important. So here it's very clear that, improved information about changing weather patterns, better meteorological information, better modeling and better forecasting capabilities, which are powered by this real-time automated pollen counting, is going to have a huge impact. But some of you who are already aware will be knowledgeable about the Copernicus program being aimed primarily at European policymakers, right? So designed to support European policies in the area of environment. But there's also this idea that the data, which is being made available freely and openly, can be taken up and used by commercial enterprises or research institutes and used to produce services that are more tailored or more specific. So Mikhail, perhaps you could talk to us a little bit about some projects in this area that have taken that forward.
Thank you, Dimitri. Probably the most interesting part and the most interesting project, which was born within Copernicus, is called PASSIFO in short. That's a personal allergy symptom forecasting if long. So the basic idea was very simple, that if we learn how to predict pollen concentrations, we learned how to predict air quality concentrations, we learned how to predict weather. So maybe we can learn to predict person-by-person symptoms. For that, certainly every person is specific. We have to learn a little bit how those people were feeling. And during last couple of weeks, let's say, when season is already on and going, and maybe knowing what will happen during next days, we'll be able to predict symptoms of every specific person for the future. That's how the project was born. It was born as a very small test case, basically, run for only 2 countries in Europe, Latvia and Lithuania. And it was 5 years ago, and it was finished already. And we came up to the conclusion that, yes, it's possible, not for all patients. It is, in fact, some quarter maybe of those who gave their information about their feelings and their locations during the last couple of weeks and during next 5 days. And of course, that's related to personal data protection and all major efforts which were put to keep the personal data secured. But in the end, the study showed that it is possible in principle. And I should say that today we actually have 2 European projects, large-scale European projects, aiming at making this kind of systems available to everyone in Europe. The projects just started, so the system is not yet up and running, but we have the first prototypes, and we believe that this will be the next step of the system towards individuals, those who directly suffer from allergy and those who can be interested in knowing the forecast for themselves. Thank you.
I mean, that is absolutely the direction that this should be going. So I'm very interested to hear about those results and seeing what could come out of that project in the future. Vincent, can I ask you about this matter of the air quality, which was also referred to before? What's the link now between air pollution exposure and pollen?
I think that's an excellent question, and actually that's still an open question. The links between exposure to Carla mentioned the links between pollen and food allergies. The link between exposure to pollen and exposure to air pollution is something that is being explored. It's clear that the exposure to air pollution has an impact on the immune function, as was very clear also during the COVID period. And so one asset that we have as part of Copernicus is to be able to provide scientists working in epidemiologists and allergologists with a complete time series combining pollens, but also key air pollutants, particularly ozone, which is a very important oxidant, and as well as meteorological factors like humidity, temperature, so that the assessment of the multifaceted exposure of patients can be seen in a more comprehensive way than simply considering specific pollens or specific allergies. So it's opening up a whole area for looking at multiple factors that may determine the response in individual patients.
Okay, so thanks for the nuanced answer there. So the Copernicus Atmosphere Monitoring Service is providing these data series on various parameters of air quality alongside the pollen, so that research can be further carried out to understand what the link might be here. And if you live in a smoggy city and there's high pollen count for a species that it may be that you're going to suffer more, so you might have to take even more remedial action. I think this is a very prominent issue, especially since air quality is, yeah, after COVID now bouncing right back to previously poor levels within cities, certainly. All right, I think we need to ask Carla now whether there is anything that the Copernicus Atmosphere Monitoring Service could do on top of that to improve its usefulness to patients and to doctors.
Thank you. I think one of the key things for us as a European-wide organisation, 45 associations nationally, is ensuring that we work closely, if possible, with these organisations, so that we have an access to connect with the patients that live with these diseases. So we have a wealth of information, but also if we can have links, for example, on our websites or links to these organisations' websites, so that there is, when people come to our websites, there's that link to these forecasts, links to these opportunities, and people then get that understanding and knowledge of what's being developed to help with their pollen allergy. I think that's a really key collaboration aspect that we think would be fantastic. And I'll just give you a quick example. Just as one organisation out of the 45 in EFA, Allergy UK, we get about 80,000 visits to our website every month. And this time of year, we get about 600 calls a month to our helpline. Majority of them this time of the year over the next 3-4 months are all about allergic rhinitis, rhinoconjunctivitis, about bronchial lung issues because of the seasons. And actually they're getting those calls are getting over a long period for the reasons we've talked today. So actually having those information links through EFA, through the national organisations as well, I think would be a really nice step in the future, so that information's accessible and people understand and know that this amazing stuff's going on.
Super, thank you very much, Carla. And I'm reminded of what you said before, which is that there's a lot of unreported, if you like, patients who are allergic, but they aren't really aware of their own allergy. And I think boosting the awareness and boosting knowledge about these forecasts is very important, so that there can be interventions made here. All right. Well, I'd like to thank my expert panel for a really fascinating and rich discussion. And I'm afraid we haven't had a good enough chance to dive into all the rabbit holes that this chat has opened up. But we do have a few minutes left. We're almost at our scheduled end time, and I think we will overrun a bit because of the late start. Just enough time, I think, for a quick question from the audience. So, or a few questions, perhaps. Let's see. So, to our listeners, thank you all very much for joining us. I see a number of you here with us today. Does anyone have any questions for our group here of panelists and speakers? All right. So while we're waiting for responses, I can perhaps just pick on a sort of a backup point here. And Carla, can I ask you, do you think that pollen should be seen as air pollution, and that that this could be recognized as a sort of a pollutant?
Thank you, Dimitri. I mean, for our allergic community, pollen is seen as an air pollutant because obviously it's having a major impact on their life when they're having a allergic reaction to the pollens. Actually, it is impacting on them, and they are exposed to that. So yes, I think it could be seen as an air pollutant. But it's a natural air pollutant. It's pollen is a natural air pollutant that we need pollen. This isn't about how do we eradicate pollen. This is we need pollen. But actually it is something that is impacting on the quality of life. So I don't think it should be an air pollutant as in something that needs to be eradicated or changed like diesel, which is another story altogether to do with impact on a kind of air pollution and how that links to pollens. So I think, it's very much linked to climate change. And I think we just need to look at information and data and how we can manage that and how we can help people living with allergies and pollen allergy to manage their pollen through data recording. And I love this idea of personal data. You can get watches now where you can get your heart rate and everything. Wouldn't it be wonderful if your smartphone or your smartwatch tells you all about the pollen level for you during that day? So air pollutant, yes, but it's a natural thing that we need within the globe. So that's my thoughts on that.
Yeah, I mean, it is indeed a sort of a natural pollutant, isn't it? It's part of the plant's reproductive cycle. We can't really ban it in the same way that we can ban diesel or petrol and these kinds of things. But thank you for that view. And I'll just turn now to, I'd like to ask Mikhail if he can comment on this. So obviously everybody is talking about AI now since last November. But can you comment on how AI is helping us to monitor pollen?
Thanks, Dimitris. That's actually probably the most important step which made the modern breakthroughs possible. The automatic pollen monitors are all based on AI. Without them, recognition of particles would be completely impossible. So this is clearly the major breakthrough thanks to AI. That's one thing. The personal symptom forecasting, that's again machine learning, not very classical AI, but one of subclasses of it. And this is once again statistical procedures dedicated to machine learning part. So yes, this is a cornerstone of the model developments.
Excellent. Very good to hear about that, and very much looking forward to how further advances in artificial intelligence and machine learning can indeed further improve the outcomes here for patients. So I think we're ready to just ask one more question to Vincent-Henri. Can you tell us, what does the future hold? I mean, what's in the pipeline? What future evolutions can we expect for the Copernicus Atmosphere Monitoring Service?
Well, I think throughout these 45 minutes, we had a very good brush of all the scientific areas where there is possible progress. I think listeners could understand that it's very multifaceted. So starting from plant biology to climate change, to forecasting technology, to artificial intelligence, to medicine. So it's really multifaceted, and what we aim to do in Copernicus and the Atmosphere Monitoring Service is to play our role in this long chain of progress that needs to be made. So on our side, the progress is in the area of increasing the number of pollens for which we will provide information. So as I mentioned already, we are at 6 different pollens. We want to increase this list. We want also to embrace this revolution of real-time pollen observation. So using them to adjust the forecast as they come. And then a big activity is to stimulate the handshaking, if you want, with the medical community. So to have medical doctors who are ready to take on this extra information and test how to use it with patients. So we can think in the future of wearable technologies and information that will enable everyone to be more independent. But I think we are still in a stage where medical doctors are really essential to see how this information can be managed to give the best possible advice to patients, so that in the end the quality of life can be improved. Indeed, it's not possible to ban pollen, so they will be around. It's possible maybe to observe them more and to have more resources into in situ observation of pollen, which is I think still lacking, and there will be a need for resources to have more of these automated pollen observations, but certainly they will be around. So how to deal with them is probably where Copernicus can play a role to help.
Excellent. Wow. Well, thank you very much. I've certainly learned a lot during the last 45 minutes to an hour, and I hope the listeners here who've joined us have also learned a lot. There's plenty more evidently to be done here, but we've certainly seen how pollen and pollen allergy is a growing problem because of the climate change effect on the growing season, on the temperature. We've seen how we've got incredible systems, European systems that are monitoring pollen. Those systems are improving. The forecasts are getting better. And there's going to be a lot to be done about increasing the links between these monitoring and forecasting systems and the medical community, the patient community. Sounds like a perfect opportunity to collaborate very much with EFA, and I do hope that if that's an outcome of this discussion, that would be a very positive thing. So I'd like to thank each of you, Carla Jones, Vincent-Henri Peuch, and Mikhail Sofiev, for joining me this afternoon. Thanks again to our listeners and followers. Hope to see you on the next Twitter space. We've dubbed them Climate Spaces, so look out for those. And I wish you all a very pleasant afternoon.